ಎಸ್, ವಿದ್ಯುತ್ ವ್ಯತ್ಯಯಕ್ಕಾಗಿ ಎಲ್ಲರಲ್ಲೂ ಒಂದು ವಿಷಾದನೆಯನ್ನು ಕೇಳ್ತೀವಿ. ಎಸ್, ಡ್ಯೂ ಟು ಪವರ್ ಇಂಟರಪ್ಷನ್ we ask sorry for everyone. We have stopped for question number 39, right? Now begin from the 39th question. See here, he has given a reaction Al3 plus by taking those 3 electrons, aluminum ion is reduced to aluminum metal. So here, on increasing the concentration of the aluminum ion, what happens to the electrode potential? He has asked. So now let us discuss regarding this one. So take the Nernst equation, that is E naught cell. E naught cell is, sorry, E cell is equal to, E naught cell not, E cell is equal to, E cell is equal to E naught cell minus 0.0591 divided by N into log of concentration of the metal divided by concentration of the ion, right? Okay, now E naught cell, keep it as it is, E naught cell minus 0.0591 divided by 3 into log of, see, concentration of the metal ion always infinity, metal is always in unity, and metal ion is kept as it is, Al3 plus, and now I will rearrange the equation, E naught cell plus 0.0591 divided by 3 and into log of 1 here the denominator term will comes to the numerator, because instead of minus I have taken plus charge, Al3 plus, right? Okay, ಇವಾಗ ಏನಪ್ಪ ಅಂತಂದರೆ ನಾನು E naught cell ನ ತಗೊಂಡು ಈ ಸೆಲ್ ನ ತಗೊಂಡು, ಈ ಸೆಲ್ is directly proportional to the concentration of the logarithmic value of Al3 plus ion, means ಏನಾಗುತ್ತೆ, as the electrode potential increases, concentration of the aluminum ion will also increases, hence option number 1 is right answer. See here, they have asked to match the following given options, list 1 with list B, list 1 with list 2. Ag plus they have taken Ag plus is produced due to Ag plus is produced due to, see here, Ag on oxidation, Ag plus an electron, one electron corresponds to 1 coulomb charge, 1 farad charge, 1 coulomb not 1 farad charge, that 1 farad charge that corresponds to 96500 coulombs. See here, Ag plus, directly see here, Ag option number 3, and Mg on oxidation, Mg2 plus 2 electrons, right? So hagadre illi 2 electrons corresponds to 2 farad charge, that is equal to 2 into 96500, right? 96500, that is 2 goes to option number 4. And Al3 plus means Al on oxidation, Al3 plus 3 electron it releases. These 3 electrons corresponds to 3 farad charge. This 3 farad is nothing but 3 into 96500 coulombs. So this becomes that is option number, that C goes to option number 2. And next Al, after that one, last option, that is Ti 4 plus 4 electrons, and here 4 electrons Ti 4 plus 4 electrons, right? Now 4 electrons is equal to 4 farad, that is equal to 4 into 96500 coulombs, that is the, so look at here, which option will favors this one? Ag3 plus A3, B4, C2, D1. The option number 3 is the right answer for question number 40. Now, catalysts are used to increase the ratio of chemical reaction because see here, the function of catalyst is a substance which promotes the rate of reaction, and here the function of catalyst is increases the rate of reaction, but during the increasing the rate of reaction there is no function of that activation energy, hence activation energy will decreases according to the increase in the function of that catalyst in the reaction. So catalyst are used to increase the rate of chemical reaction, means catalyst ಅನ್ನು ನಾವು ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡೋದು ರೀಸನ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ catalyst ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಇದೇನ್ ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ ಇಟ್ ಗಿವ್ಸ್ ದ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಟು ದಿ reactants. So ಹಾಗಾಗಿ reactants are adsorbed on the surface of the catalyst and that will weakens the bond and form the products. There is no function of the activation energy, hence it decreases. Next, half-life of first order reaction is 20 seconds and initial concentration of the reactant is 0.2 molar. The concentration of the reactant left after 80 seconds is question number 41. We'll see the answer. Yes, K is equal to right, they are given K is equal to 0.693 divided by 20. The value of this is 0.0346 per second, and that is of the concentration of AT is equal to concentration of A naught into e raised to minus KT. So AT, A naught value, now A naught means AAT into e raised to minus K value is 0.0346, 0.0346 into the value is into 80. This will becomes A into 80, that is the value of AAT is 0.2 into e raised to minus 2.772. The value of e raised to minus 2.772 is equal to, this will becomes 0.0625. Substitute this in the equation, 0.02 into 0.0625. This will becomes 0.0125, which is the right answer. That is 0.0125 molar is the option number 4 is the right answer for the question number 42. And now in the graph, energy of activation he has given, it is a energy of activation graph. This is a potential energy and this is a reaction coordinate and this is a energy distribution curve. Here energy of activation he has given, how much he has given? 215, and change in the enthalpy, that is he has given 9, this is kilojoule and 90 kilojoule change in the enthalpy, and activation energy for a reverse reaction is equal to energy of activation minus delta H. See here, energy of activation is 215 minus 90, this will becomes 125 kilojoules. What is the answer for this one? That is option number 2. Yes, here he has given in 44th question, for the reaction 2N2O5 gives rise to 4NO 2 plus O2. The initial concentration of the N2O5 is 2 moles per liter, and after 300 minutes it is reduced to 1.4 mole per liter. The reaction of production of NO2 is in mole per liter per minute, he has asked. Now let's begin. That is concentration of change in the concentration of N2O5, that is equal to how much he has given, that is initial final minus initial, that is 1.4 minus 2. This will become minus 0.6 minus 0.6 mole per liter. Now minus 0.6 mole per liter, and rate is equal to change in the concentration of R is equal to change in the concentration of N2O5 with respect to time. Change in the concentration, he has given minus 0.6 divided by, he has given 300 minute. This will become, this is mole per liter and this is per minute, and together 0.02 mole per liter per minute. Now what we have to do? Now rate of that is rate of NO2 concentration, that is equal to 2 into rate of N2O5, that will becomes 2 into 0.02, that is equal to 0.004. This will becomes 4 into 10 to the power minus 3. 4 into 10 to the power minus 3 is the answer. R is equal to, the right option is option number 1 for 44th question. Which of the following methods expressing the concentration are unitless? See, molality concentration term, its unit is mole per kg, and molarity mole per liter, here only I will solve. For molality the unit is mole per kg, and molarity, that is equal to C is equal to mole per liter, and the mass percent. See here, he has asked, which of the following methods of expressing concentration are unitless, he has asked. Here 2 are unit, they are with unit, and 2 are unitless, they are mole fraction and mass percent are the 2 components which are unitless. Okay, and select the incorrect statements for the following. 22 books have infinite significant figures. 22 books have infinite significant figures. And next, second one is in the answer of calculation of 2.5 into 1.25, the answer will be 3.125, and which is reduced to the rounding of 3.12. Again, if we rounding off this to 3.1, there are 2 significant figures, hence option number 2 is incorrect. And zeros preceding to non-zero digits are significant, he has told, but according to the statement of significant figure, zeros preceding to the first non-zero digit are non-significant, and hence option C is wrong. And in the answer of the calculation of 12.11 plus 18 plus 1.012 has a 3 significant figure, but actually this one is, after adding these all, we get 5 significant figures out of, he has given 3 only, hence this statement is also wrong. So the incorrect statement among the following 4 are B, C and D, option number 2. And 47, given below are the atomic masses of the element. He has asked to find out the Dobereiner triads. So option number 1 is the Dobereiner triad, and option number 2, calcium, barium, strontium, or strontium, calcium, barium are the Dobereiner triads. Iodine, chlorine, bromine are also the Dobereiner triads. This one is not the Dobereiner triad, hence he has asked which of the following doesn't form triads is the option number 4. And here in the change in the hybridization of aluminum of the Al atom in the following reaction. See here, to finding out of the hybridization, we have a formula. By applying the formula, we get that is yes, hybridization is equal to here is a formula, number of valence electrons of central metal atom minus number of monovalent atom plus or minus electrons divided by 2. So by utilizing this formula, we calculate Al. First, AlCl3, Al in AlCl3. Look at here, in AlCl3, the hybridization is that is equal to number of valence electrons 3 plus number of monovalent atom, that is 3, divided by 2. Number of monovalent atom, that is 3, that is equal to 3 plus 3, 6, divided by 2. How much? 2 electrons. See here, 3 electrons, very sorry. This one, 3 electrons. These 3 electrons corresponds to sp2 hybridization. 3 electrons corresponds to sp3. So sp2 hybridization, 1 for S and 2 for 3, total 3 electrons forms sp2 hybridization. And for Cl4 minus, this is quite different, that is equal to 3 plus 4 plus 1, 3 plus 4 plus 1, that is number of electrons, 3 plus 4 plus 1 divided by 2, that is equal to 8 by 2, that is equal to number of electrons is 4, and these 4 electrons responsible for the formation of sp3 hybridization. So like this we have to calculate. So the hybridization changes from sp2 to sp3 in aluminum, and match the following statements. See here, the number of valence electrons in the bonding molecular orbital and anti-bonding molecular orbital divided by 2 is used to calculate the bond order. And here the number of valence electrons in the bonding molecular orbital and anti-bonding molecular orbital in first option A, 10 minus 5 divided by 2, that is equal to 5 by 2 is equal to how much? 2.5 for option number 1. And for carbonyl number B, this is 10. This is 10 minus 4. 10 minus 4 divided by 2. This is equal to how much? 6 by 2 is equal to 3. And for C, this is O2 minus the bond order will become O2 minus, this is 10 minus 7 divided by 2 will becomes 3 by 2 is equal to 1.5, and option D, that is 10 minus 6 divided by 2 is equal to 4 by 2 is equal to 2. So from this, according to this one, 2.5 NO 2.5 and CO is 3, and O2 minus is 1.5, and this one is 2. From the above so, calculations, we got A4, B3, A3, the option is A3, B4, C1, D. The option number 2 is the correct answer for the 49th question. And for 50th question, he has given the electronic configuration of X. X means this is a what? Non-metal, and this is also a non-metal according to the electronic configuration. When we come across the 15 atomic number is goes to the phosphorus, and this one is 17 goes to the chlorine. That's what phosphorus and chlorine combined together forms the compound of the form X of the form XY3 type with covalent bonding. And now 51st question, again here they have given 51st question. 51st question, see here they have given the option number, first question number 51, match the following types of reaction with examples. Combination reaction, where the combination taken place. So combination antantandre two or more molecules combined together to form a single atom. See here he has given combination reaction is A combines with option number 3, and for the decomposition reactions a single atom decomposes to form more than 2 atoms. That is option number 4 for the decomposition reaction. And displacement reaction, the displacement reaction is corresponds to C1, that is the displacement reaction in Cl2 plus 2Br minus 2Cl minus and Br2. There is a displacement reaction takes place, and disproportionation reaction is the reaction in which the single atom shows 2 types of oxidation state in a reaction. So hagagi illi ಏನು ತೋರಿಸ್ತೀವಿ, from this combination we get the option. The right answer is A with 3, A3, B4, C1, D2. The correct option is 4. And 52 question, in the following pairs, the one which both transition metal ions are colorless. See here, scandium 3 plus, option number 2 is the right answer for this one. I will show how it is. Scandium 3 plus, scandium 3 plus means scandium, the ground state atomic number of the scandium is 21, and after losing the 3 electrons it will gains the noble gas configuration of 18. Hence it does not form, there is no unpaired electrons in its outermost orbital, hence it forms colorless compound. And Zn2 plus is also in its ionic state, Zn2 plus in its ionic state it will forms D10 configuration, hence there is no unpaired electron in its outermost orbital, hence this is also forms the colorless compound. And in 53rd, in the reaction between hydrogen sulfide and acidified potassium permanganate, what will happen? Let us see. The reaction is KMnO4, yes, 2KMnO4 plus 5H2S plus H2SO4 gives, it will produces K2SO4 plus Mn2MnSO4 plus 5 sulfur plus again 8 moles of water. So here what happens? The sulfur oxidized to H2S, in sulfur in H2S oxidized to 5 moles of sulfur, and MnO4 is reduced to Mn plus 2. So here the reduction takes place and here the oxidation takes place, hence option number first one is right answer. A member of the lanthanoid series which is well known to exhibit +4 oxidation state, that is none other than cerium. And in which of the following pairs both the elements do not have n minus 1 into D10 NS2 configuration means ಇದರಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥದ್ರಲ್ಲಿ ಔಟರ್ ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ನ n-1 into D ಮತ್ತೆ NS2 ಕಾನ್ಫಿಗರೇಷನ್ ಯಾವುದು ಒಂದಿಲ್ಲ ಅಂತಂತಂದ್ರೆ that is AG and CU. Look at here, the electronic configuration of CU is 3D10. This is 3D10 4s1 and that is of silver is 4D10 and 5s1. Hence these two are not shown the above electronic configuration. And 56th, a ligand which has two different donor atoms and either of the two ligates with the central metal atom or ion in the complex is called as, that is ambidentate ligand, because it can donate from either of the two side of anyone from the two ligating atoms. And 57, which of the following statements are true about NiCl4 2 minus? It is a tetrahedral geometry because it is a sp3 hybridized one. Due to that reason, in its outermost orbital. And coordination number of Ni2 plus is, this is wrong because the central metal atom is coordinated with 4 Cl atoms. Hence, the coordination number of the central metal atom is 4 and the oxidation state of nickel is +2, but here they have made small mistake, and it is a high spin complex, and the complex is paramagnetic. So that's what option number A, option number C, option number D and option number E are the right answers. A, C, D, E is the option number 2. And which formula and its name combination is incorrect, they have asked. ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ನಾಲ್ಕರಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್ ಆಗಿದೆ, ತಪ್ಪಾಗಿರೋದನ್ನ ಹುಡುಕ್ರಿ ಅಂತ. ಸೊ ಫಸ್ಟ್ ಒನ್ ಏನಿದೆ, ಡಯಾಮೈನ್ ಕ್ಲೋರಿಡೋ ನೈಟ್ರೇಟೋ N. Here nitrate group is bonded coordinated with N, hence it is right. And platinum 2 compound or complex, and K3Cr C2O4 tries, this is potassium trioxalatochromate 3, this is also right. And third one is dichlorido bis ethane 1,2 diamine cobalt 3 chloride, this is also right, and these three are right. And here pentamine carbonyl they have given, here they have given carbonato, carbonyl they have given here, and here in the complex they have given carbonato, hence this is the wrong one and incorrect one, hence option number 4 is the right correct option. In the complex FeC2O4 tries, the coordination number of the Fe is, this is a dientate ligand, oxalato is a dientate ligand, hence it coordinate with 2 donor sites and 3 oxalate together forms 2 3s are 6 ligating atoms, hence the coordination number of the central metal atom is 6. And the last one is match the following of reagents with the structural prediction. Acetic anhydride, yes, the last one is acetic anhydride gives the reaction of glucose. Acetic anhydride reaction of glucose has 5 hydroxyl groups in the reaction, and bromine water reaction, when the glucose reacts with the bromine water, it forms glucose as a aldehyde group. Glucose has an aldehyde group, it is used to detect the aldehyde group in the glucose. And hydroiodic acid is used to, glucose has a straight chain, hydroiodic acid is used to identify the glucose as a straight chain, and this one is as it is, and the right option is option number 3. Thank you, my dear children. Now I am very thankful to the management and everyone has given. I am very thankful to the management and our HOD for giving me an opportunity to represent this in front of you for solving this question paper. Thank you one and all.